Hello everyone, this is Dr. R. Sasikumar, Professor, Computer Science and Engineering Department from RMDEC Engineering College. Today I am going to take about catch replacement policy. So in catch replacement policies, we have a number of algorithms. From this example, I am going to discuss about two algorithms. One is a least recently used algorithm, another one is a first in, first out algorithm. So consider for this example, consider the following reference string 78548186418145485785785 and assume that a number of page frames that catch can hold at a time 3. So there are 20 strings available. What about that catch size means what? The catch can hold at a time only 3, the page frame. So there are 3 questions. How to implement LRU catching scheme? Find the number of page fault using the least recently used page replacement algorithm. The second question, how to implement FIFO catching scheme? Find the number of page fault using the first in, first out page replacement algorithm. And despite these problems and find out which one is the better. We will see one by one. So the first one, catch replacement algorithm, that is LRU, least recently used algorithm. What is that LRU algorithm in part? This algorithm which replaces the page that has not been used for the longest period of time is referred to as a least recently used algorithm. So which page is not used for longest time? That page, whenever the page size is full, then that longest period of time pages will be replaced. So according to this example, the LRU algorithm produce 12 page fault. So these are the reference string. I already told there are 20 strings available. Then we will implement with the help of LRU algorithm. So the reference string one by one, you can fill there. What about the catch size means what? The catch page size is only 3. So the very first time the string is 7. Initially the catch size is empty. So 7 can be filled. The second one, the another string is 8. 8 is not available in the catch and still we have a 2 more space. So the 8 also filled in that page frame. The third example, third string is 5. The 5 is not available in the catch and one more slot is free. So one more page frame is free. So you can fill 5 also. Now the catch page frame is filled. 3 slot is occupied already. Now we need to replace one data. So which one will be replacement? What 785. The 7 is not used for longest period of time. So whenever the new data arrival, then the with the help of LRU technique, the oldest data will be replaced. So with respect to this example, the new string 4, whenever the 4 comes, then the 7 will be replaced. So instead of 7, the 4 will be placed. So 4, 8, 5. So the 4 is recently used and the 5 also recently used and the least recently used is what? 8. So when the next data is 8, 8 is already available. So the hit occur. The next data is 1, but 4, 8, 5. So recently 8 is referred by that slot and 4 also recently referred and least recently used to 5. So instead of 5, 1 will be placed. Again, the slot is filled. So we need to replace one more string. The new string is 8. So that is already available in the catch. So hit occur. Okay, whenever the requested data is available in the cache memory, then the hit occur. If not available, then fault will occur. So the new data is 6. So with the help of LRU algorithm, instead of 4, you can replace 6. Again, the slot is filled. Then which one is least recently used means what? 1 will be least recently used. So the new data 4 comes, then 1 will be replaced. So 684. Again, the slot is filled. So the next data 1 that is not in the catch frame, page frame. So 8 will be replaced. Again, the slot is filled up. Then the new data is 8. 8 is not available in that page frame. So with the help of LRU technique, 6 will be replaced. Again, we have to apply that 814. In that 814, the new data is 1. So that is already available. So hit occur. Again, 4, that is also already available. So hit occur. The new data is 5, that is not available. So with help of least recently used, right, instead of 8, 5 will be placed. Again, the slot is filled. The new data 4, yes, it is already available. So hit occur. The next 8. Among 3, which one is replaced means what? 1 is not used for longer period of time. So instead of 1, 8 will be placed. Again, the slot is filled. The new data is 5. 5 already available. So hit occur. Then again, the slot is filled. The new data is 7. That is not available in the cache memory. So the 4 is not used for longer period of time. So instead of 4, 7 will be placed. Again, the another data 8. So 8 already available. So hit. Then again 5 already available. So hit. The 20 strings are over. So with respect to this 20 strings, there are 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 12 page fault 12 page fault occur, and 1, 2, 3, 4, 5, 6, 7, 8 hit occur. So the number of hit ratio is what? 8 divided by 20. The number of miss ratio is nothing but what? 12 divided by 20. So the number of page fault occur with the help of LRU technique, 12 page fault. That is, I already told that in the previous slide I have mentioned already. So the LRU it produces 12 page fault. The next one, the same data with the help of FIFO algorithm, first in, first out, a replacement scheme in which the block is replaced is the one that has been entered first in the cache memory. So which one is entered first, that will be removed first. So that is called what? First in, first out algorithm. The FIFO algorithm produced a 15-page fault. So we will check how it will be produced a 15-page fault. The same string is used in the FIFO algorithm. So the first data is 7. So initially the cache memory is empty. So the 7 is filled. This is what first entered. The next entered is 8, also filled empty. So 8 is available. The third data 5. The slot is empty. So 5 also filled. Now the page frame is filled. So which one is removed now? Among 3, which one is entered first? That data will be removed. So 7 is entered first. So whenever the new data comes, then the 7 will be removed. So instead of 7, 4 will be placed. So 4, 8, 5. The next data 8. 8 is already available. So hit occur. Then 1. So now the second, which one is entered? The next 8 is entered in the cache memory second time. So instead of 8, 1 will be replaced. Again, the page frame is filled. Then third data 8 comes, that is not available. So instead of 5, you can place the 8. Then 6 is not in that page frame. Which one is entered first? 4. So instead of 4, 6 will be placed. Then again 4 is not in the page frame. So instead of 1, 4 will be placed. Again the page frame filled. 1 not available in the cache memory. So instead of 8, 1 will be filled. Again 8 comes. Instead of 6, 8 will be placed. Then 1 is available hit. Then 4 also available hit. Again 5, that is not available in that page frame. Instead of 4, 5 will be placed. Again the slot filled. The new data is 4, not available in that page frame. So instead of 1, 4 will be placed. Then the new data is 8, already available in that page frame. So hit occur. Again another data 5, already available in that page frame. So hit occur. The 7, which is not available in that page frame. So which one is entered first? The 8 will be removed. Instead of 8, 7 will be placed. Again 8 comes, that is not in that page frame. So instead of 5, 8 will be placed. The next data 5. So 5 not available in the page frame. Instead of 4, the 5 will be placed. So there are 15 page fault occur in that FIFO algorithm. There is a 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. So number of hit 1, 2, 3, 4, 5. So 5 divided by 20, that is a hit ratio. 15 divided by 20, that is a miss ratio. So among these two, which one is better means what? Despite this problem and find out which one is better. LRU replacement produce a 12-page fault. FIFO is produced a 15-page fault. So obviously, LRU replacement algorithm is better than the FIFO algorithm. I hope you understand this cache replacement policy algorithm. Thank you.